Hello again. So let's look at this next problem. A cone with vertex A, height AB equals 9, and radius BC equals 12 is given. So let's just start by drawing that out. So whenever I draw a cone, I do this kind of semicircle like that, and connect two lines on the side to form what would be the vertex A. Now draw the little dash lines behind it to represent the area or the part of the base that we can't see. Now we know the height AB, so that goes from the top straight down, hitting the middle of the base, so somewhere around there. We're going to call that B. We know that has a length of 9, and the radius AC, which would be somewhere there, has a length of 12. And this is forming a 90-degree angle. Now, let's see. After that, we have the cone is cut in two pieces by a plane perpendicular to AB at point X. So, what's going on is that we have our cone, and a plane is going to come and cut at it horizontally because that would be perpendicular, 90-degree angle. So let's think about how this shape would end up being cut by the plane. Well, if it's perpendicular, meaning being cut horizontally, and if you imagine a cone sliced in half like that, then you would be left with another kind of circular cut somewhere over here, where this point would be X, and that we have AX is 6, which means that BX must be 3 because the whole height is 9. Now, it wants us to find the volume of the two smaller pieces. So let's consider the volume of maybe the entire cone, because that could definitely help us out. Because I don't know what this bottom portion shape is. It's called a frustrum, but we don't know how to find the volume of that shape, but I do know how to find the volume of cones. So the volume of the entire cone is 1/3 pi your radius squared. Now the radius of the entire cone is 12. So you have 12 squared times the height, which is 9. Well, that becomes 1/3 times 9 is just 3. So you have pi times 12 squared is 144 times 3, which can be reduced as 432. So we have 432 and then our pi left over. Now this represents the volume of the entire cone. What we need to find now is the volume of the top piece, which is also a cone. I'm going to call this point here point Y. Now, why would I do that? Because I need the radius of this smaller cone in order to get its volume. So, that radius would be like XY, making another 90-degree angle. Now, how can I find out what XY would be equal to? Well, if you notice, we have two sets of triangles, AXY and ABC. And I can prove that they're similar to each other because they both have a 90-degree angle, and they both share this angle BAC or XAY. They're both the same angle. So we know that triangles AXY and triangle ABC are similar due to angle-angle similarity. which means their sides are proportionate with each other. So if I'm trying to find xy, which is the radius, let's set up a ratio to do that. So the radius of the smaller cone would correspond to the radius of the larger cone, 12. That must be equal to, well, the height of the smaller cone is 6, and the height of the larger cone is 9. Now, we can reduce that into just, well, 6 over 9 is the same thing as 2/3. And that can be simplified as r over 12 equals 2 over 3, which means that the radius, well, if we multiply 12 on both sides, well, 12 divided by 3 is 4, times 2 is 8. So this radius xy must be 8, which means now we can find the volume of the smaller cylinder. So volume, I should whatever. The volume of the smaller cylinder, I'll just put volume small, is 1/3 pi r squared, which is, our radius is 8, times the height, which is 6. Now, that volume, well, we know 1/3 times 6 is 2, so we have pi times 8 squared is 64, times 2, and then we get the volume of the smaller cone is 64 times 2, which is 128 pi. So that is the first part of our answer. Now, the second part, we need the volume of the other piece, this piece right here. So that volume, again, that's called a frustrum, so I'm just going to put volume of F is equal to, well, that's simple. It's the entire volume, the volume of the entire cone, minus the volume of the smaller cone. So 432 pi minus 128 pi. So, doing that subtraction, we have that 432 minus 128 gets us that the volume of the frustrum is 304 pi. And that is our problem solved. So just take each part one step at a time, and logically, I mean, think of it, we're just using old material. The only thing that might throw you off is the similarity to find the radius, but it is something hopefully we know how to do. But anyway, that is it for this problem.